Okay, so you think it's a combination. But what would you have? Combination is however many options, right? And then how many you're picking goes here, right? So it's two numbers, options, and then how many you're choosing. So what would you do? You're going to put all this together? Three separate. Okay, but then what do you do with those three separate ones? Multiply. Goes back to the counting principle. So this first one, the meats, our options for meats, we have how many meats? 4, and we're choosing how many? 2. It is a combination because the order doesn't matter. So it's going to be 4 factorial divided by, now for a combination, do we have the number on the outside of the parentheses?
Yes.
Yes. So it's going to be 2 factorial, how many we're choosing, times quantity, 4 minus 2 factorial. So that's going to simplify. Again, what does this simplify to? 2, so that's what I'm going to take the numerator down to. 4 times 3 times 2 factorial. All over 2 factorial times 2 factorial. So those will cancel, and I'm left with 4 times 3 divided by 2 times 1, which is just 12 over 2, and that is, so I have 6 different combinations of 2 meats having 4 options. Okay, how about cheese?
Well, we can only pick 2.
You can only pick 2, and we have how many options? 5, so it's 5 choose 2, order doesn't matter. So we have 5 factorial divided by 2 factorial times quantity, 5 minus 2 factorial. So what am I going to take the numerator down to?
3.
3, because 5 minus 2. So I have 5 times 4 times 3 factorial over 2 times 1 times 3 factorial. I started to do it on this one. That way I don't have this extra step right here. 5 times 4 is 20. 2 times 1 is 2. And 20 over 2 is 10. Here's my question to you. How many breads are you picking? Just 1. So you have how many different options? 3. So what's the point in doing 3 choose 1? It's just going to be 3. Do you need to see that, or do you understand what I'm saying? If you have 3 breads and you're picking one of them, you're choosing one, then it's just 3 options. But you could verify that. I mean, you really shouldn't have to, but 3 over 1 is 3 factorial over 1 factorial times quantity, 3 minus 1 factorial. Do you see what's going to happen? 3 times 2 factorial over 1 times 2 factorial gives me 3 over 1, which is just 3. I mean, I can see that though, can't you? You just have 3 options. You're picking 1 bread. So now what do we do with these? Multiply them together. So 6 times 10 times 3 gives me 108. Why do we multiply instead of add?
I want to say that it's because it's like a standard operation. But like you add the combinations, it's not giving all the potential ones. Like
Well, it kind of, it's not exactly, but it's kind of like going back to the probability, right? You want this and that. These 2 meats and those 2 cheeses on that type of bread. So this and that, right? So this is the fundamental counting principle, but that's why. Instead of adding, you multiply, okay? All right, do the next 4 examples. All right, try them, work through them, and then we'll go over them together. Okay, so he was asking me, he said, you know, you're torn. Is it a permutation or a combination? Think about it. Don't you have a locker back at baseball? You don't have a locker?
we don't have to use them.
Oh, okay. Well, think about the lock. You get assigned 3 numbers for your lock, right? Can you put them in any order and it open? No. So does the order matter?
So it's not okay.
Order
so it wasn't
matters.
asking you just to pick 3 numbers. It was saying to get the law.
Right. Order matters, which means it is a permutation. And welcome to the world of mathematicians, because we hate the fact that they're called combination locks. They should be called permutation locks. Drives us bonkers. Yep. So we have 40. We're gonna place 3 of them, right? Because the placement matters. I used to say pick, but Sarah told me first block that if you say place, it makes more sense because you have to place them in a certain order, or like place you finish in a race. So the formula is 40 factorial divided by, what goes in the denominator? Does the 3 go on the outside? It's permutation. Talk to me.
The 3 would go on.
It's just 40 minus 3, right? A combination would have the 3 factorial on the outside, wouldn't it? So what am I going to put in the denominator? It simplifies to 37. So that tells me right there to take my numerator from 40 down to 37. Okay, and thankfully I can simplify that. So 1, so it's just 40 times 39 times 38, which is
59,280.
So folks, those lockers that you don't use, that are in the hallways, but are just there for viewing pleasure, apparently. If you have a combination for it, which should be a permutation, there's 59,280 options. That's if it has numbers up to 40. What if it went up to 100?
Hold on, I got it. 970,200.
Can you believe that? It's crazy, right? All right, how many different 5-member committees could be formed from the 100 U.S. senators? We have 100 U.S. senators, don't we? So whenever they have these little committees of 5 people, how many different committees could there be? Does order matter?
I would say no.
Order does not matter, right? If you're on the committee, you're on the committee. It doesn't matter if you're picked first or last, right? Order does not matter. So that should help me, right? Is it a permutation or a combination? It's a combination. So I have 100 members, and I'm choosing how many? 5. So it's 100, choose 5. So what goes in the numerator?
100.
100 factorial divided by
5 factorial.
5 factorial times quantity
100 minus
100 minus 5 factorial. Good. So what am I going to take the numerator down to? 95. So 100 times 99 times 98 times 97 times 96 times 95 factorial. All over. And I'm going to go ahead and write out the 5. 5 times 4 times 3 times 2 times 1 times 95 factorial. So that cancels out. And we get what for the numerator?
Well,
It's a ginormous number, right? Yes.
9,034,502,400.
Proud of you for just calling that number out. All over. We did it a while ago, didn't we? 120. The 5 books on the shelf, right? And you end up with 75,287,520. Y'all, we have 100 members of our Senate. Do you realize this is a real world problem? Can you believe that? Doesn't that blow your mind? Think about it. There's 80 students here at gun school. So if I made a committee of 4 people, how huge, how many different possibilities that would be. Isn't that crazy? All right. Have you had time to do these 2? No? All right, go for it. All right, Michelle Cook has 7 essays to include in her English 1A folder. In how many different orders can she arrange them? So does order matter?
No.
Yes, it does. It's a permutation.
Oh, sorry. That's what I did.
So you would have 7 factorial over 7 minus 7, right?
Yeah.
Order matters. The first essay is not going to be the same as the last essay, right? It's like the bookshelf thing. But what happens? You get 7 factorial over 0 factorial, which is just 7 times 6 times 5 times 4, and you should have got 50, 40. Okay?
Is it okay if we did like you did? Because I didn't like when I looked at this one, I was like, and I just thought about the bookshelf one. I was just drew 7 lines instead of 7 times 6.
Yeah, it's fine.
It just went straight.
That's the same thing. All right, how many different ways could first, second, and third place finishers occur in a race with 8 runners? Order matters. So it's a permutation. This one is also just like this one. So we would have 8 place 3, right? So 8 factorial over
8 minus 3.
quantity 8 minus 3 factorial, which gives us, I'm not going to finish simplifying. I mean, you should be able to do that part, and you should end up with 336. Y'all, it's a race with 8 people. What if there's a race with 20 people? Wow, way more options, right? Isn't it blowing your mind? I just think it's crazy. Okay, so look, and now, so we're finally to the binomial probability stuff. Okay? All that stuff, though, is super important. So here's an experiment. And first of all, I was like, why are we doing this? Well, I'm not just going to say, this is binomial distribution formula, memorize it. I want you to explore it, okay? Because you'll have a better understanding of it. So here's your experiment. There's a 4-question multiple choice quiz. Look at the multiple choice quiz, though. How many options do you have? 3. Okay. So let's say you randomly guess the answers to this 4-question quiz. All right, and you have 3 options for each one. And I said circle the best answer. So construct a tree diagram where C is the correct answer and W is the wrong answer. So let's talk about that first question. I'm going to help you because first one was like, think about it. Your first question, how many options do you have? How many different outcomes?
You can choose 3 answers.
Well, you can choose 3, but in the end, you're still either going to get it
Right or wrong.
right or wrong. So it's either going to be correct or wrong, right? So then the second problem is either going to be
Correct or wrong.
correct or wrong. So do you see how to do this? I want you to finish it, okay? Go ahead and finish your tree diagram because then we're going to finish talking about it. So then the third question, you still have the options correct or wrong, right? Ooh, they're going to be bunched up. Put it down here more, okay? And then on the fourth question, you'll still have correct or wrong, right? So the first one would be correct, right? The next one would be correct, wrong. So this is if we have 4 corrects, this is if we have 3. So then if I follow the next one, it would be correct, wrong, correct, right? I just didn't finish it. Do you see what I want you to do? I want you down the side. But now, before you do that, here's the last step, because you're going to have to do this part for homework, okay? Correct. What's the probability of getting it correct?
Like all of them?
Just let's say this first one. What's the probability of getting this first one correct versus the probability of getting it wrong?
1/3.
Quick. Good for you. How'd you figure out 1/3?
Because you have 3 answers.
You have 3 answers and only one of them's right. So the probability of getting it wrong is
2/3.
2/3. So to get correct would be
1/3 times 1/3
1/3 times 1/3 times 1/3 times 1/3. So the probability of getting all of them correct is 1 out of 3 times 3 times 3 times 3. What is 3 to the 4th power?
27 times 3 is 81 and 2 is
81. 1 out of 81. Do you see what I want you to do? So finish figuring out all the possible outcomes and write how many are correct. So this is the number correct. Why am I having you write that? Well, look what X is. Number of correct answers. I'm having you determine X right here. So write how many is correct, write the possible outcomes, and then beside it write the probability of you getting that. Okay?
So if it's, now let's say we have more than one that's 3.
Right.
Rewrite it, or you still want to write out each one? Like as in like.
If I give you a homework problem, you mean?
No, like for this.
For
You
this?
should want to do this for homework.
Oh, you're saying if there was another one like, let's say C, C, W, C, and it has 3?
Right.
No, just put
Whatever it is.
whatever it is.
Okay.
Yeah. No, you don't have to write it out every time.
Okay.
Good question. Thank you. Anything else? I don't see you again until Tuesday. Tuesday we'll finish this. Okay. You need to do what over the weekend though?
Study.
Start working on your project too. Okay. All right.
Study.
Yes, studying is super important though. All right.